Okay, so we said last week that we have different types of data mining tasks that we are going to discover along this course, right? One of them was predictive task. So predictive task means that you are looking to predict some value for the future, okay? Because we have other types of data mining or machine learning algorithms we're gonna discover along the way. But one of them is predictive. And we have two types of algorithms that we're gonna talk about, which is classification and regression. Anyone remembers what regression and classification? Or at least what's the difference between them? Anyone can recall? So classification and regression, firstly, they are predictive tasks, two types of predictive tasks. The difference between classification, you are trying to predict text value or categorical value. So if we check or take this example, creditworthy, the items or the answers for this label or this column is yes and no, right? So this one, you can think of it as categories. Or maybe like another example, if we have here gender, then male and female, okay? And so on. So when you have categorical variables or text variables, then in this case, you try to do, if you wish to do predictive task, then you need to use classification. Because regression, on the other hand, regression, what do we do? So regression, when we have continuous value. So when we have continuous value and we wish also to do prediction, then we need to choose regression algorithms. We cannot work with classification, okay? So let's say I'm trying to predict the years at present address. Then this is gonna be my label variable, which is y. And then in this case, I cannot apply classification, but I take regression. Same data set, but it depends on which column is your y. What are you trying to predict? So in other words, here I cannot do annotate. I think I'm using, because the mobile version, well, many people. Okay, I already shared. Are you able to see the screen? Can you just confirm those who are attending online today, for today? Are you able to see the screen? Okay. Okay, so if this is your y, or maybe here I can use this one. And so if this is your y, let's say this column is your y, and of course in this case this is going to be x1, x2, right? And this is x3 in this case. Then I cannot apply classification. I cannot apply classification for this task. I need to go with bus, right? I need to go with regression. So if I have my label column is continuous value, then cannot go with classification. I need to look for regression algorithms. On the other hand, if this is y, like the example here, and this is just one of the input variable, x3 in this case, then it's correct to use classification. So always you need to inspect, you need to ask yourself what I'm trying to do in this task, what is the data available? Then based on it, you identify your x, the input variables, and the output variable. Based on the type of the output variable, you can determine whether you need to go with regression or classification. Clear? Okay. So actually, we already covered these, but just I'm going again. So prediction for customers, in this case, my class or label, same. So always try to understand the terminology, what we are using. So we are talking the same language, right? At least you know what I'm talking about. You don't feel like you are aliens while attending this course. So class or label, same thing. So here my label let's say I have a column which shows me whether such a customer is loyal or disloyal. Okay, in this case also it's going to be classification problem. Yeah, so we stopped last time here. So what is association analysis? This is another type of also data mining task. In association analysis, usually we work on, let's say, market basket analysis. In this case, that means, let's say, like when you go to Lotus or Ion or whatever, then you have your customer card, right? Every time you do purchases, all the transaction you do, they're going to be recorded, correct? So what type of machine learning or data mining can we apply on such data? One of the interesting things that you can do is you can apply association analysis. So association analysis, in case you have like the market basket analysis or even medical informatics information, then the point is you try to extract rules. But these types of rules, so this is like an example of the data set. It's going to be like, so the first transaction, this person has purchased these products. Another transaction, these products were purchased, and so on and so forth. So based on this data, we may try to extract some rules. And these rules can help us to do many things like sales promotion. These rules, if I give you an example, these rules are going to be like saying if a person has put in his cart bread, there's high chance probably he's going to purchase milk. Okay, this is raw data. This is not processed data yet, but just I'm saying later when I apply data mining, I should get such rules like this. Okay, I can now demonstrate you on Colab. You can see. Then these types of rules can help me to do sales promotion, meaning I can promote these products together. Let's say bread and milk. So that means I can encourage the customer to do more purchases, right? I can provide sales promotion based on the rule which says that if a customer has placed in his cart bread, there's a high chance he's going to purchase milk as well. Also can help me to do shelf management. Since customer, I found out that there's a high chance to purchase milk once they place bread in their cart, then I can put these items on the same shelf next to each other to make it easier for them, right? Or maybe on the other hand, maybe if you know that customers are going to purchase this, you put one item at the beginning of the store, the other one at the end. So you make them pass by all the other shelf. Maybe hopefully they can purchase other products as well along the way, right? But you have some information, you have some knowledge, you can take privilege. Inventory management, right? Also you can know that how you can manage your inventory for the products you have in hand. Okay, so always is good if we have some demonstration. Even I cannot copy. High security. Have to access 100 times. Okay, so here, this is, I put you an example for association analysis. So you see that here, what I got here the transactions for the products that customers have purchased. Okay, so let's say if any of your relatives has maybe a small shop, then you can convince them that let me do FYP project. You take their data set, right? You ask them to provide you all the sales that they have done for maybe a year or two. Then you can do machine learning. So this is my data set here. So you see that this is one transaction where people have purchased milk, onion, I don't know what is this, and so on, kidney beans, eggs, yogurt. Okay, so this is my data set. Then we cannot talk about how we can process the data later anyway, but the point is after we do association rules, association analysis, we should get something like this. This is the interesting part. So we got the antecedent and the consequent. Antecedent means something's going to happen first. So based on these association rules that have been found by applying data mining, it says if the person has placed eggs in his cart, there's a high chance that he's going to purchase kidney beans as well, based on this data set. Okay? And the confidence is 100%, is 1. Oh, it's too high. That means all customers, once they put in their cart eggs, 100% sure that they are going to place milk as well. Okay? So confidence is like accuracy. It's actually accuracy. Another example here, if they put kidney beans, so this is actually the opposite. Okay? Or onion, then they're going to purchase eggs, milk, kidney beans, and so on. So these kind of rules that you can extract for market basket analysis. Okay? Interesting or not? Not interesting. You don't care. Whatever happens, sales, promotion, no sales, nobody cares. Okay? So this is association analysis. We try to find rules, extract rules from the data set, right, based on the items that purchased. And then we also try to find some metrics showing us like confidence and lift, how confident you are that if the customer has placed eggs, that he's going to purchase or place kidney beans as well. So this can be also like if you are using, you are building website, right? So sometimes also you can tell them customers who have bought eggs, right? Usually they also buy kidney beans. So maybe you are promoting other products as well, right? This happens on some website. Once you intend to purchase something, usually they will tell you that these are the items usually people purchase together, in case you are interested as well. Okay, so association analysis application also can be used for web traffic analysis. If you have data set showing how where the user goes to which web page, how long he stays in these web pages, then also you can conduct association analysis to find these rules from the data. Another task also we can conduct in machine learning or data mining. So we talked about predictive task and association analysis, clustering. Clustering means grouping. That means you intend to group objects or let's say records together. Let's say I have records about all of you inside my data set, like your age, which state you come from, and so on and so forth, your height, and I wish to group you up based on these features or these characteristics that I know about you. Now, if I'm asking, I just like to divide you up or cluster you into two groups based on your gender, do I need to apply data mining? Is it a big deal? Think about it. If I bring you up here and I ask you, please help me to cluster this student inside this class into two groups based on their gender. Is it a big deal? Yeah, it doesn't require data mining. So not always you need to throw data mining into the surface, right? Saying, okay, data mining is the solution for everything. Some cases doesn't require data mining, okay, like this one. But let's say I got a lot of characteristic about you. Your favorite color, favorite food, right? Your favorite destination, how you like to spend your weekend, and so on and so forth. Now, if I bring a lot of this information into here, then it becomes so hectic for any person to try to cluster, to group you up. And also, or maybe even it's impossible. So data mining can assist you in this case. Clear? So if I ask you later, let's say in the quiz, like, do these kind of tasks requires data mining or not? So you need to reason, you need to think. If I ask you, group up students based on their gender, this task is simple, doesn't require data mining, right? Even if the data set is already inside the database, you can just write simple SQL, right? So group by gender, if you remember. So easy. But if you have too much or too many data, a lot of data characteristic about your, let's say, the people that you're trying to cluster, or maybe the objects, maybe you have data set about objects, cars, and you like to cluster them. So in that case, it would require some algorithms to help you. So clustering, where is one of these tasks which can help you to group up objects together. That, of course, that they are more similar to each other. Okay? So clustering, defining a group of data points. Data points means records. So we have a table, we have a data set, I have Excel file sheet. Each row inside the Excel file sheet is called data point or object or row of data. Okay, so please keep these terms aside so you remember every time what is data point when we mention. Doesn't mean there's a point drawn on the wall. Okay, but it means that you have a row of information of data about some object. Okay, so grouping data points similar to each other, right, in one group and different than other objects in another group. Okay, so for that is to say, now this one not working, high intra-class similarity and low inter-class similarity. So the point is we try to find similar objects, right? And then we group them up, and those that are different, we put them into another group. Of course, not necessarily we may have two groups. Maybe we can determine we need 3 groups, 4 groups, 5 groups. It depends. Okay. I think I don't need to click. Otherwise, I have to verify 100 times. Clustering should be somewhere. Okay, so this is an example for clustering. This data set is about flowers. So here they have collected 150 records about flowers, and the features we have, like the sepal length in centimeter, the sepal width, petal length, petal width. Okay, so we have 4 features, and we wish to cluster them up into 2 or 3 different groups. So if you check here, I'm looking to group them up, those that are similar, right? I need to group these data into 3 different groups. Then you see that here, the result based on the data mining, that the first records here, all of these are means in one cluster because they got same label, 111. So if you notice here, actually, I have what unique values I have. I have 1, 0, and I have 2. Correct? Because I requested for 3 clusters. And those clusters have been given just some number. That means I have cluster of ID 1, cluster of ID 0, and cluster of ID 2. Okay? So now when I pass the data set, again, if you check .predict x, then it's going to tell me for each flower where this flower should be located. Is it in a group ID 1 or group ID 0 or group ID 2? Clear what these numbers are? People are asleep with open eyes. So clear what these numbers? So just like I'm giving ID to each group. And then the algorithm, it tells me where each of these flowers should be located. Then I know now, based on this clustering group, I can just have all the flowers of cluster ID 1. I can check them. And then I have another cluster for ID 0. I have different set of flower. And then for cluster ID 2, I have a different set of flower. Those that are located in the same cluster, that means they are so similar to each other and different than the other, the other flowers in the other cluster. Okay? Okay. Another example for also interesting one for clustering, doing color segmentation. Okay, so also inside, if you like, again, for those who have laptop on this side, if you access Colab and the code, and then you can do some changes. Already there's an example I already updated for color segmentation. So here, this is also one example of clustering. So I got a picture about this flower. Now this flower has many colors, right? Orange in different grades, dark orange, and so on. I have green, I have yellow, some yellow, black, and so on. And I would like to reduce the number of colors inside the image. So I can apply clustering. Okay, so here also I'm looking for 3 clusters. So the result should look like this. You see? You see or you see? So here, as a result, after applying clustering, I got 3 clusters. That means some pixels fall into the black color, some pixels into the orange, other pixels to the green. Only 3 colors. This picture has only 3 colors. This picture has millions of colors. So this is another example of color segmentation. If you have, you can replace here the picture. You can find any other picture from the internet and just change the link here and then observe the output. Also, you can change here the number of clusters. Maybe you like to group the pixels into 4 different clusters or 5. Then just change here the number of clusters. So color segmentation is another example of clustering. Marketing and sales as well can be helpful. Like you can, let's say, based on the information about your customer, right? You can group also those customers into different groups and then target them with different marketing strategy. Okay, so also you can group those customers that maybe look similar in terms of the features available, again, gender, the amount of money they pay on their purchases, their location, level of education, and so on and so forth. Then you can group these customers all, and then try to have for each cluster, you see what is the overall, or let's say the common characteristic among them. Maybe one of the cluster is mostly about student. Let's say if I check cluster 1 after data algorithm has done, then I inspect what data mining has found. Maybe I can check, see, for example, cluster 1 includes majority are student. Okay. Then I can, in this case, prepare marketing targeting student. Correct? Maybe another cluster is about those businessman people. Then I can prepare other things for them. Maybe another cluster is for women. Then when I prepare advertisement to target them, I put women in the picture. I don't put kids or student, correct? So you can target each group differently. Document analysis. Also, you can group up different documents into different cluster and then inspect and see each cluster what they contain. Maybe one cluster is about entertainment, another cluster is about politics, and so on and so forth. So you can also do. The point is what I'm doing in all these examples, I'm grouping up, right? I'm dividing, like the example here, this is a nice one. I have a lot of pixels, correct? But after all, what I have done, I have clustered these pixels into only 3 groups. Either the pixel should be considered under the green cluster, or the orange cluster, or the black cluster. Only 3. While here there were many clusters, many groups, or many colors, you name it, correct? So after all, I'm interested only to reduce, in this case, the number of pixel, the number of, not pixel, the intensity of the cluster of the pixel from 0 to 255, and then only 3 values. Either the value should be orange, or it should be black, or it should be green. That's all. Anomaly detection is also another example of data mining we can apply. So an anomaly detection, as the point or as the name means, I'm not sure. Do you know what is anomaly or anomalous or outliers? Anyone would like to share his voice? Rent his voice for 10 seconds. What is anomalous? If we say something is anomalous. Sorry? Yeah, exactly. So it means it's not normal, means it's outlier. Okay? So one of the cases where data mining you can apply is where you would like to build an algorithm that can help you to find some anomalies inside your data. Let's say you are working in a company and the company has production line for, let's say, smartphones. Okay? And this company would like to apply data mining. So what data mining can do? One of the examples where they can apply data mining for is for anomaly detection. So what does that mean? That means the algorithm should pinpoint or raise, let's say, an alarm when you are producing a phone after the production of the phone. because you collected all the information, maybe the weight of the phone, I don't know, all the features you have, then the algorithm will calculate or do the calculation required in order to see whether this smartphone that you have produced is most likely is outlier. That means that it might be malfunction or there's a problem, or it falls under the normal. Normal means that the phone is supposed to be working. Otherwise, if the company produces mostly outliers, that means all the products they produce mostly, they're going to be thrown away. Okay, so the majority smartphones should be working. Some of them should be outliers. So anomaly detection can raise a concern about the product that is produced. There might be some problem in it. Then maybe a person in charge will inspect and see whether data mining algorithm has raised a correct alarm, or maybe it was false alarm. Okay, then they can inspect. So here also is an example for anomaly detection. So we got some dummy data here, dummy data, and then we are trying to inspect those that are outliers. So now if you check here, when I pass for prediction, the data points I have, okay, so after I prepare the training algorithm, which is in this case Gaussian mixture, then I calculate the score. I do some calculation for each and every data point object. Let's say it's about smartphones, so I calculate score for each smartphone I have. Then those that they fulfill, or actually I can, based on some threshold, then I can predict whether such a product is anomaly or not. So in case it's a true, that means it's anomaly. Otherwise false, it means normal data. So if we check here, majority of the data set, the data points I have falls under false, means they are normal data, except for a few cases where I have true, true, true. So these are anomalies. These are predicted to be anomalies. Okay? One more thing before I continue, something to draw your attention. It's about clustering. We used before same data set, if you notice, same data set was used for classification, correct? Same data set is about flowers, iris flowers, okay? But if you check the number of columns I have 1, 2, 3, 4, 5, correct? For clustering, I have only 4. Why? Why there's no flower type here? The label. So in classification, I had same data set plus 1 extra column tells me the flower type. In clustering, I didn't have, because in classification requires Y. Y, we have X, these all are X, X1, X2, X3, and X4. This is Y, okay? So this is labeled data set, correct? This is labeled data set. While in clustering, doesn't require that, because clustering requires unlabeled data set. It's unsupervised learning. We're going to talk about soon. Okay, so just keep that in mind. So data mining application, classification, flagging, like flagging offensive comment also, maybe inside discussion forum or maybe Twitter. This is also under classification. Forecasting your company revenue for next year. This one is more under time series. Okay. Another example also of data mining, like predicting credit card transaction as legitimate or fraudulent. This is also classification. Predicting land covers, whether it's urban area, water bodies, or forest. This is also classification, because I'm trying to predict text. Correct? I'm trying to predict text here. These are text. Predicting tumor cells as benign or malignant. It's also classification. Predicting a news article, whether it's finance, sport, or politics. Classification. Predicting comments on discussion forum as offensive or not is also classification. Okay. Now we move on into the types of data mining algorithms. Data mining algorithms can be categorized into different categories based on three criteria, main criteria. Whether or not it's a human supervised, whether, in other words, requires labeled data or unlabeled data or partially labeled data. Okay, so this is, we call it whether or not human supervision required. Comparing new data points to detecting pattern. This is also based on how the data mining algorithm itself works. I'm not going to cover this section. And whether it can learn incrementally on the fly. This is interesting, but also I decided not to cover this time. So this is about batch learning and online learning. Some algorithms can learn along as you add up more data. Let's say today I got 1,000 records. I let machine learning work, the model, the algorithm. Then tomorrow I got extra 10 records. Do I need to retrain the model again or the algorithm on the 1,010 records? 1,000 from a long time ago I have. Today I got a new 10 records. If yes, I need to merge all the data and then retrain. This is called batch learning. If the algorithms allow you to incremental learning, that means today I got 10 records. I just let the algorithm complete training on only the 10. Tomorrow I got another 10. I push the new only 10 to the algorithm to update itself. If this is the case, then this is called online learning. But anyway, I'm not going to cover these two. The focus is only whether or not human supervision required. So this, which leads us to the next slide, which is about supervised or unsupervised learning. Okay, so what is supervised and unsupervised learning? Data mining system can be categorized according on the type and volume of training supervision that they receive. Based on this, what does that mean? Soon you will understand. We have four types. We have supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Anyone knows anything? Especially the expert. I'm still on the quest to find the three experts we have in this class. Now I have some suspects, right? But yet I need to confirm. So anyone like to share with us what is supervised learning? Supervised? What does supervisor do? Just think of it. Reason with it inside your mind. If you have supervisor, anyone does FYP without supervision? You are so confident already. You are a lecturer and you don't need any supervision. So what does supervise do? Give you feedback, right? Whether what you are doing, let's say, is correct or incorrect, right? Let's take it just that simple, not too many things. Let's say just the supervisor has to say good or bad. That's all. So, and then what you do, you learn from your mistakes based on the feedback, and you try to do correction. So this type of learning is called here also supervised learning, meaning I have to tell the algorithm when start training. Let's say I'm trying to predict whether the work the student has done is good or bad. So I have to present the work to the algorithm. I tell the algorithm, okay, look, this is a sample of the work. This is bad. This is a sample of the work. This is good. This is another sample of the work. This is bad, and so on and so forth. Only in this case, these types of algorithm will learn. Okay, so these are called supervised learning. Another example, like if you are trying to build a classifier to say whether such an email is ham or spam, like the example we showed earlier. So we have to present the email to the training algorithm and say this email is ham. This email, another email, and this email is a spam. Another email, this email is ham. Another email, this email is ham. So that means I have to tell the algorithm while I'm providing the data whether these emails, what they are. Are they ham or spam? So I have to supervise. I have to provide, to teach the algorithm, to provide this piece of information to the algorithm in order to learn. Clear? So this is called supervised learning. Unsupervised learning, the opposite. The algorithm doesn't require you to feed back anything or provide any label, like the clustering. Just now I showed you. So in clustering, we didn't have any label, correct? We didn't say this, let's say, we were talking about iris data set. So we didn't tell the algorithm whether this flower is from flower type 1 or flower type 2 or flower type 3. Nothing. Just I fed the data into the algorithm. Okay, so this is called unsupervised. Semi-supervised, where the majority of the data is unlabeled, but I got few instances are labeled. Like the example, partially labeled. You remember? Inside Colab, I showed you cases for partially labeled, where the majority of the data set is unlabeled, and just you got few instances which are labeled. So this is called semi-supervised. Reinforcement is something different. Anyway, I'll show you an example. So for demonstration purpose, you can go to DM support GitHub and check data types file. Okay, so this is an example about emails, correct? And then here I have to feed the algorithm whether the first email is a spam, second email is ham, and so on and so forth. So this one is called labeled data, and the training algorithm to do such task is called requires supervised learning, because I'm feeding the algorithm the sample, or let's say the data set, the emails, plus what they are, each email, whether it's a spam or ham. So this is labeled data set, and this is for supervised learning. I use this type of data set for supervised learning, okay? For unlabeled, let's say same emails, but this time I didn't provide label. So in this case, I cannot use supervised learning because supervised learning algorithms require label, and now you have no label. Then you need to think about unlabeled algorithms, the algorithm that requires no label data, like clustering. Okay, clustering doesn't require labeled data set. Then I can go with clustering. Partially labeled, where the majority of the data set, but here only I have 4 records, but should be the majority of the data set got labels like spam and ham. And sorry, the majority of the data is unlabeled. That means they have no label, like the case here, none. We don't know what their label is. We have no info what their label is. Only few records inside the data set you have, they are labeled. So this is called partially labeled data set. And for this kind of data set, you need to go with semi-supervised training, okay? Okay. For supervised learning algorithm, we're gonna, I think, cover all of these. We have k-nearest neighbor, linear regression, logistic, support vector machine, decision tree, neural networks. All of these are supervised learning algorithms. This is the example for spam and ham classifier. So you notice how it is supervised, because for each email, I already put label whether this email is ham, this email is a spam, this email is ham, this email is a spam. Okay, so this one have to go with supervised learning. Another example, let's say here I'm looking for the car price value, and here is some feature, feature 1. And then also, since I'm providing y, this is y label, correct? So this is my label, or y. This is the label axis. My font is nice, right? You see, I can write nicely. Okay, so here, this one is my column, sorry, the axis for y. So this one is also supervised. So this is x1, some feature, and this is y. Okay, for unsupervised learning algorithms, we're going to talk about k-means. Just now we saw demonstration when we clustered the flower into 3 types of pixels from high many pixels to density to low or reduce the number of density, sorry, for the class for the pixel. We use k-means. We have dbScan. We have okay, this is under clustering. Association rule mining, we're going to talk about a priori. For visualization and dimensionality reduction, we're going to talk about principal component analysis later on. Okay, now we move on to unsupervised learning. So unsupervised learning use unlabeled training data. Okay, as you would guess, without a teacher. That means there's no supervisor providing labels for each record inside your data set. Okay, here is another example of also unsupervised. It's good sometimes just to understand why we are learning these algorithms. So what ability, what applications can be applicable for. So on this data set, let's say you are running a website, okay, and you got information about your visitors that are coming to your website. Okay, in this case, what you can do, probably you can go with clustering, unsupervised learning, which can group or cluster your visitor into different clusters or different groups. Okay, so consider the scenario when you have access to a lot of visitor data for your blog or website. If you want to find groups that are with similar visitors, you might wish to use clustering technique, which is unsupervised. For instance, you might observe that 20%, after you do clustering, of course, you might observe that 20% of your weekend visitors, maybe in one cluster, are young sci-fi fans, whereas 40% of your visitors are guys who enjoy comic books and read your blog most often in the evening. Okay? Yeah, there are different types of clustering. Then you might use this to tailor your post to various groups. Now you have some information about your groups, 40% who they are, 20% who they are, okay? Then you can tailor post for each group. Same like case for marketing. Now you know that, let's say 20 or 40% of your customers are young. Then maybe you target them with a marketing strategy where you put young people, let's say in poster or in advertisement. You don't put maybe elderly people, for example, or vice versa. Okay. Also, anomaly detection, where you try to find flaws, right? Anomalies, it's also unsupervised. Doesn't require Y label. So you can check also the demonstration earlier. When we talked about anomaly detection, there was no Y. Anomaly detection, you see, only X. Only X. There is no Y. Okay? So anomaly detection is also unsupervised learning. Semi-supervised learning, as we said, the majority, where you have majority of your data points or instances are unlabeled. You don't know who they are, to which class they belong to. Some algorithms can handle partially labeled data in this case, because here, if you see most of the data points, they have no category. We don't know whether they are triangle or square, the label. The majority, while we got only few instances which are labeled. Okay? So this requires you semi-supervised technique. Okay? One nice example or application of semi-supervised, let's say you got like Google Photo. This is an example for Google Photos. One of the photo hosting service, when you submit all of your family pictures to the service, it will automatically detect that person A appears in picture 1, 5, and 11, while person B appears in picture 2, 5, and 7. This algorithm's unsupervised portion is going to do clustering. So put all these people that maybe appear in these pictures, like in 1, 5, 11, in one cluster, another people in another cluster. And then this is so far unsupervised, unlabeled. Okay, the system just needs from you now at this portion, at this time, you identify this individual at this point. It can name every individual in every shot. That means I go to cluster 1, and I see, oh, majority of the photos are my photos. Then I point that this is me. Then the clustering algorithm is going to know in this case that all the other photos belong to me too, because I belong inside this cluster. My photos inside this cluster. The second photo or the second cluster, let's say, is about my son. Then I put his name. That means all the other photos inside the second cluster belongs to my son. You see how it's semi-supervised? So we started with unsupervised. Just we cluster the data into different groups. Then it's enough just to name one picture, let's say from cluster one picture only to give label. I mean, one pictures in cluster one picture from cluster 2. That's it. That means all the rest of the photos inside cluster 1 belong to that person, which I already named. And the second cluster, the rest of the photos in cluster 2 belong to a second person, which I named as well. So when I named these instances, it has become partially labeled data. The majority unlabeled. We have no idea who these people are inside this picture. After clustering, then I give name, at least one name for each person. Then this is what it says here. Now you need to identify this individual at this point. It can name, once you identify them, saying this person is my friend, this person is my son, this person is my student. Then it can name every individual in every shot with just one label added, which is helpful for searching photos. Okay, so when you do searching, that means you don't need to go to every photo and say, this is me, this is me, this is me, this is me. Okay, just you cluster the photo, say, and then later you give the label for one of your photos, then the algorithm will label all the other shots that look similar to you. That means all other photos are you inside the other photos, like inside Facebook, right? They are able, just you name yourself in your profile, you show some pictures of your profile, and then maybe you have tons of photos, right? But later is able to identify you in all the other pictures that you are there as well. Reinforcement learning is something kind of totally different than all of these. Reinforcement learning is based on the idea that, actually like we do with a human. Let's say you are maybe, I don't know, if you have pet at home, let's say a dog, then what do you do when you like to train your dog or your cat? When it does something good, what do? You punish, right? When it does something bad, you give food. Then it becomes naughty cat, destroy everything at home. The opposite, of course. So if your cat has behaved well, then you give some reward, correct? Maybe some food the cat likes. When the cat does something bad, maybe you take the food away, correct? This is exactly reinforcement learning, okay? This is reinforcement learning. So reinforcement learning means the algorithm try to learn from the environment. When the algorithm does something good, you give some reward. When the algorithm does something bad, you give penalty, and so on. Okay? Now, in this video, this is very nice example about reinforcement learning. We have a hen here, and this hen has been trained to pick or to choose, let's say, the pink color. Every time the hen choose the correct color, is going to be rewarded, given some food. Okay? So now, of course, you're not going to see any training going on. The hen is already trained, but at least it demonstrates the idea. So notice what happened. You see, they gave her two colors, still able to pick the right color. You see? And then you give reward. Every time the hen does well, you give some reward. You see now so many colors or so many pieces, but still able to pick the right color. Okay? So this is reinforcement learning. This demonstrate to you reinforcement learning. Would you like to see again? Okay, so this is the concept of reinforcement learning. We're not going to cover that in this course, but at least you have an idea what reinforcement learning is about. And same in ChatGPT. So now ChatGPT is also reinforcement learning. You give some feedback sometimes when the answer is correct, right? They give you, maybe you can check or tick that this answer is correct. Then that means you are rewarding, giving some reward. If it's bad, then you say, maybe you, when you answer back, you tell them, no, you didn't answer well, or this is incorrect. That means you are giving some penalty in this case, kind of like you are telling this is bad, and maybe the algorithm inside will give some penalty to ChatGPT that it has gone in the wrong direction. Another nice example, if you have heard of SpaceX, anyone heard of SpaceX? Right, it's famous. So actually they also applied reinforcement learning. What they have done, usually when you launch, let's say, rocket to the space, right, it has two parts. One part will push, let's say, the object or the rocket up to the sky, correct, to the space. And then at some point, it will split. That the first part will fall down into the ocean. The second part will continue out of the space, going the journey out of the space. So what SpaceX has done, has applied reinforcement learning to do what? And instead of losing part one going into the ocean, it's still expensive, right? They spend a lot of money to build part one. So they tried, after part one has completed its journey by pushing part two out of the space, it will try to go back to the Earth and land correctly on the Earth. Rather than going into the ocean, it will try to go and land back correctly on the surface of the Earth. So you can use part one again for another launch. Okay? Actually, the video is not here. Maybe later I share it with you, where they had some try and how they were successful. They were able to launch the rocket at some point. Then the part one was able to land successfully back to the Earth by using reinforcement learning. Okay? So as this one demonstrates to you, how that the part of the rocket was able to land back successfully, back to the Earth. So of course, in this case, they have saved a lot of money, and they were able to promote or maybe have more sales. I mean, targeting people to send maybe equipment to the outer space with lower, I mean, investment or lower amount of money, because they were able to reuse part of the rocket again. Okay, so these are the four types of machine learning, either supervised, unsupervised, semi-supervised, reinforcement. There are other classification or categories for machine learning algorithms, but I'm not gonna talk about in this course, like batch learning, online learning. Okay, what else? Instance-based algorithm and model-based algorithm. Anyway, none of these I'm gonna discuss in this course. Would you like to have a break? Yes? Okay, then have a break, 5 minutes. Then we continue. In the meanwhile, if you have a question, you can ask. Okay. So what are the main challenges of data mining? Okay, clear? I go next one. Okay, there are a few challenges that happens when you work on data mining project. The first one is insufficient quantity of training data. So data, as you see that, it's all required for even supervised, unsupervised, doesn't matter. Data is the main component for data mining algorithms. So you need to ensure that you have sufficient amount of data. Otherwise, if you have low number of data, like the cases in demonstration, all of them, they have very few sample, right? Though I got high accuracy, like 100%, but actually most likely I have what's called overfitting. We're gonna discuss about it soon, meaning the algorithm has memorized the data rather than extracting rules out of it. Okay. So data sufficiency is something important to have for training algorithm. Okay, so here is also another example, this from Microsoft. As you see, the more data you have, the amount of the accuracy start to increase. This is about the test accuracy. We're gonna also talk about, usually we split our data into training and testing portion. So here, when they apply the algorithm on the testing portion, the accuracy start to increase as they increase the amount of data that they have. Okay. Here they are using naive Bayes. This is one of the algorithm. Perceptron means neural network. And there are other algorithms like memory-based and WinNow. Memory-based is the instance-based algorithm that I'm not going to cover in this course. So why data is important, like here. So the point is, when you try to teach the algorithm to extract rules, if you have low number of data, then the algorithm have high chance of memorizing this data. Like, for example, if you are attending, let's say, data mining for 14 weeks, then I give you just maybe 20 or 30 slides to study. Of course, I'm going to tell you to study. But some of you may choose to do what? Since, oh, only 20 slides, 30 slides, just I memorize, I do well in the final exam, correct? So the point, and regardless whether the student is hardworking or less hardworking, so they're going to achieve probably good mark on training data set, but on testing data set, of course, they're going to do very bad. But the point is, the amount of data is essential. If you have low number of data, the training algorithm might not extract rules, but memorize the data. Non-representative training data is also another problem. If you don't have representative data set, let's say I'm trying to predict the age of student, or maybe the mark, the performance mark, final exam mark for student. But yet, when instead of taking all your data, I selected few samples from your data set, okay? But this data set is not representative, doesn't represent the majority of you inside this data set that I have introduced to the training algorithm. Then also training algorithm might learn something about you which is not true, not correct, because I didn't provide representative data set, okay? So having representative data set is also another challenge. So here in this example, this is also in your main reference, from your main reference. If you remember regression, we're gonna talk about, but it's about predicting continuous value. So this one, the Y, is about predicting the life satisfaction, okay? And then let's say I didn't provide enough data. So originally, this is the solid line, the black one, was based on some data, only those red color. Small amount of data, and it's not representative. While the dot, the blue one, is the rest of the data set, the rest of the data set. Now, if I take these blue lines, blue dots from the training algorithm, then the algorithm might find out that this line is more suitable based on the information that is provided. But this actually is not so true, because the actual line that the algorithm should learn is this one, the blue, the dot blue line. Okay? So is this a big deal? Yes, this can be a big deal, because here, if we check, this is about GDP per capita in USD for different countries. Like here we have Brazil, Mexico, Chile, and so on. We have Switzerland, Norway. So if you check the first line, the black one, it looks like those people from even high income country or low income country almost have the same level of satisfaction. Correct? Check. If you just draw a line coming down here to the y-axis, and also here on the y-axis, I'm talking about the black line, then the level of satisfaction, let's say, is very near to each other. That means it doesn't matter whether you have high income or low income, your satisfaction is almost same. Is it true? You will be same satisfied if you have low income or high income? It doesn't matter, right? Of course, right? So people like to have higher income. But why the algorithm has learned that way? Because the data at first that was introduced to it wasn't so much representative of the reality about the whole data set. So this is why when you need to train an algorithm, you need to ensure that the data that you have provided is representative. Now the question is how I can have representative data set. Let's say I have records about million of students, and I don't want to train the algorithm for the million records. Maybe I want only to train the algorithm on, let's say, 800,000 records, but yet I need those records to be representative. Then I can do random sampling. I can randomly try to pick records from this data set, because random sampling is one of its characteristics. It will overall have the same characteristic inside the sample data. The sample data should have the similar characteristic of the overall data. So the point is, again, I need to have representative data set. Let's say, again, just to make it simpler, another example, if I'm trying to predict the final mark for the student, imagine that I didn't include high performance student, just I took low performance student and maybe or mid and low performance student. Okay, would you think the algorithm has the reality picture about the performance of the student? No, because the data set is not representative. I should have picked some student from high performance student, some student from low performance student, some student from middle performance student. Then the algorithm will understand or extract the right rules from this data set. But if I hide some of the data, which actually can give another part of the picture or the story about the performance of the student, then the algorithm might mislead, might understand something else. Okay, that means maybe the majority of the student cannot perform and approach a high level. Okay, even if they spend hours of learning. You got the picture? So this is why representative data set is one of the things that is important when you wish to train data mining algorithm. Another problem is poor quality data. Poor quality data means you have outliers inside your data set, or you have missing values inside your data set, noise, or errors. Okay? So outliers is anomalies, like just now what we mentioned. Let me give you a very nice and simple example. Now, what is the trend about the car price? Is it the newer car higher price, or the older cars have higher price? Let's say I have same car, same brand, same model, but one was manufactured in 1990s and another car was manufactured in 2020. Which one would have the higher price? The old or the newer one? Of course, the newer one, right? And same does for all other brands, correct? So it's a trend. We all know if you are looking for newer car, that means you need to put more money to purchase. So let's say I'm building an algorithm to predict the car price, how much the price for a car should be. And inside the data set, I have included some antique car. These antique car, what are their characteristics? Maybe it has been produced way so long time ago. Okay, let's say it's in 1940. But how about the price is going to be low or high? High. All right, those antique car. I don't know how long they can go, but those antique car, some people are willing to pay or put a lot of money to them. Okay. So if I take also antique car and put to the data set and then introduce to the training algorithm, what would happen? The training algorithm will become will become confused to some extent or distorted, because the original trend should be that newer car, higher price. But then I got some cars inside the data set which is way old yet expensive as well. So this actually can distract your training algorithm, and then it can actually lead to bad data mining project. So what I need to do, if my intention is to predict the car price, and I found that there's outliers. The outliers here simply are the antique car, those that do not go with the norm. The norm is the newer car, higher price, but those are old, yet they are expensive as well. So these cars I have to take away before I start training. So the algorithm is not distorted, okay? It's not distorted. So this is why quality of the data is important. You need also to invest time to check your data, whether you have outliers or not. Then you need to treat these algorithms. One of the treatment is to remove them, like the car price. I need to take these cars out of my data set, okay? Now, what would happen if I keep them again? Nothing gonna happen, huh? The PC is not gonna explode. But the point is, the algorithm is not gonna train well. It's gonna be distorted, okay? So this is about outliers. Missing values, as the name indicates, that some portion of the data for some people, let's say I'm collecting data about student, some information are missing. I don't have them, okay? Then also missing values can cause problem to the training algorithm. We need to treat these missing values. We're gonna talk about treatment later on. But please keep in mind, your data set shouldn't have missing values. If it does, there are some treatments that you can apply. Some of them you can remove these records, okay? Or you may do some treatment we're gonna talk about later on. Noise. Noise means that your data set, how could I explain it to you in simple words? Because this is not easy, but the point is, if you check sometimes, just to give you in very simple words, if you check on Muda, let's say, and you look for same brand car, same color, same year of production, and so on, would you see all these cars will have exactly the same price? No, right? Some of them might be, I mean, let's say it is 20K, but maybe I might find some results where the car is 30K, right? There are some people wishing to sell their car at a higher price. Some people, maybe they are in need for money at this time. So they are willing to sacrifice and sell their car at low price, correct? So this actually can also produce, this is considered noise, because we cannot determine what is the right price for this type of car manufactured on the same day, same color, same size, engine size, and so on. So this is considered noise, okay, inside our data set. So also there are treatment for noises, how to work out on this data set. Like, if you like to understand noise in another example, like if you are talking on the phone and then there's a machine working beside you. So that means what your let's say voice detection algorithm is going to be also at some time not able to work properly because there are some noise going into your voice as well while you are talking. Yeah, so something like this. Another challenge is irrelevant features. You are so happy, just you want to start training the algorithm, but you don't have the right data. Okay, you provided any data, just any data you found into the training algorithm. So what's going to happen? Let's say you are trying to predict the car price, but then you got some features inside your data set which is irrelevant. Means actually it doesn't make any difference whether it has this value or this value. Okay, then in this case you are just introducing some data which has no relevance whatsoever. Let's say whether the car has the size of the key for the car. Is it maybe small or maybe it's a bit big? I don't know. Just I'm giving you something is irrelevant, right? Everyone knows we don't care. If I tell you maybe it's the key car length is more 10 centimeter or less 10 centimeter, it's something irrelevant, correct? Most of the time, nobody cares. So when you introduce some irrelevant data to your training algorithm, also your training algorithm is going to give you irrelevant answers later on, because you have simple word to remember is garbage in, garbage out. You gave garbage data to the algorithm to train, then on the prediction time is going to give you also garbage. Okay, so meaning irrelevant data I have introduced to the training algorithm is not important, it doesn't make any difference. Then also the training algorithm is not going to learn anything, so it's going to give you also garbage at the end. Now we come to another challenge which is overfitting. Overfitting and underfitting. So what does it mean, overfitting and underfitting? Maybe I give you a simple example. Always try to understand. If you understand, I'm sure you won't forget these concepts even after you finish this course and go to another course, even graduate, you're gonna remember this. So try to reason. Let's say I'm sure inside any class, there are 2 types or 3 types of student. Let's say if I got overfitted student, because it's about our topic, and underfitted student. So what does it mean, overfitted student? Means this student doesn't bother much to study the actual concept behind the course. But he doesn't have time, let's say, and he decided just to memorize whatsoever. You give him example inside the slides, he go and memorize without understanding why we done step 1, step 2, step 3, step 4. It doesn't matter, just he memorize. So after all, if the lecturer and the student was so lucky, he got the same example in the final exam, same one that he memorized, he's gonna achieve very well, right or not? He was lucky enough. He just memorized the example inside the slide, and he was so lucky. He got it with numbers, everything inside the final exam. Wow. Then you see them smiling inside the final exam. You don't know what's happened. Start writing. He get full mark. Okay? But is this student has actually captured the concept behind the course? Of course not. Okay. Now, what would happen to the same student? He wasn't lucky on the day of the final exam, and the lecturer has decided to give different numbers. Same example, but different numbers. He has changed all the numbers inside the example. What would happen? Will the student achieve high mark for this question? Of course not. Very low mark, maybe even 0, probably, or maybe just few marks. This is exactly what we mean by overfitting. Overfitting means the training algorithm has memorized the data rather than capturing the concept behind it. And how I can detect these kind of problems? Same. I introduce a new problem to the algorithm with different numbers, like the case for the student, and then you will see that it's gonna get very low mark. And then I introduce the same example with same numbers that the algorithm has trained earlier, is gonna achieve very high mark. So they're gonna be very huge discrepancy. Sometimes achieve very high, but if you introduce data that has not been introduced earlier during the training time, the algorithm is gonna do very bad. That means overfitted. The algorithm has overfitted, has just memorized the data to pass the final exam. But if you introduce new data that the algorithm has not been seen before, okay, then the algorithm is going to do very bad. Same exactly case for any student if he decided to memorize. If he memorized and he was lucky with the same example, same number, he's going to do well. If he was unlucky, same example with different numbers, then he will fail. Okay, so this is overfitting. Underfitting is different case where, let's say, the student doesn't bother to study at all. He just maybe show up inside the class, but he never study anything. So of course, it doesn't matter whether the lecturer has brought the same example with the same number in the final exam, or same example with different numbers in the final exam, is going to do bad anyway. Correct? Logically, he's going to do bad anyway because he didn't spend time to understand anything. So this is what we mean by overfitting and underfitting. Overfitting means the training algorithm has memorized rather than capturing the real pattern inside the data set. So later, when I introduce the same data to the algorithm is going to do very well. When I introduce new data to the algorithm is going to do very bad. When I see there's big discrepancy, in this case, I say the algorithm has overfitted. Okay, has overfitted. But if I take another algorithm and then I use same data to test, I see it has done very bad. Then I use another data with another numbers, new numbers, then also done very bad. So any bad anyway means this is underfitting case. Okay. So if you check here, this is why I put here too much study, just to keep in mind Like someone, but of course, too much study, it's not negative, but meaning the algorithm has memorized rather than capturing the pattern behind. So if we check, let's say I have introduced or projected my data set in 2D. Okay, so the optimal case, let's say I got this data, the line, the algorithm that should discover the pattern inside the data, the line should look like this. Okay, where the error amount for the training data, that means based on the training data the algorithm has used to learn, is going to be low. And also when I introduce new data to the algorithm, the error is also going to be low as well. This is the optimal solution that you can find. That means a good solution. Overfitting, on the other hand, you see how the algorithm has memorized? These, the stars one, are the training data. So the algorithm has tried to memorize, has spent a lot of time, let's say, try to memorize. So the error on the training data is going to be low because it has memorized the training data. But when I introduce test data, which is unseen data, the error is going to be high. So this is why it says low training data, high test error. The underfitting should be bad anyway. So high training error, high test error anyway. This means underfitting. You see? Just I got straight line, and this line didn't capture any pattern inside the data, while this one has captured some pattern, but didn't memorize. This one has memorized the data like this. Clear? Okay, so underfitting, just now I explained. Too little study means the algorithm has not trained anything, just as a student just showing up inside the class. I'm not sure if probably talking also, then doesn't study after all. If he or she studies after the class, then that's good. But if it doesn't study at all, then that's bad. Now we come to another thing that to keep in mind is about testing and validating, is to monitor how well your algorithm is doing. This is another challenge. Let me explain in simple words. If now you are all attending this class and I'm giving you all the materials like the slides, the practical examples, and so on. Now, if I need to test you in proper way, in a way that could reflect the actual performance to each one of you, okay? Would it be proper if just I bring examples from the training data, means from the materials, same example, copy paste from the materials that you have studied? If I bring this kind of example, I'm sure that a lot of you is going to achieve very good mark, right? Correct? Because it's the same data that you have used to training. Let's say I give you examples is how to do classification. Okay? Then on the test time, I brought you the same example with exactly same numbers. Would that really reflect your performance? For some of you might achieve, let's say half of you have achieved A. But for those who have achieved A, doesn't really reflect the exact performance for them? Not necessarily. Some of them have maybe spent good time and studied, and they actually achieved A by their, because they have spent good time and studied. But some others, because they were lucky, they got the same example with the same numbers, they were able to recall what they have studied from the slides and then just do the same or provide the same result. So how to overcome this issue? Because in training algorithm, maybe we spend time, we are training the algorithm. Then we test the algorithm based on the training data, and we see the algorithm is doing very well. We are very happy and satisfied. We pass the trained algorithm to production to use in real life, then the algorithm does very bad. So how to do? What we do, we take the data set and then we split it up into training and testing set. So when we need to train the algorithm, we push the training data. But when we need to test, we use the test set, because the test set is some data is considered unseen to the algorithm. The algorithm have not seen during the training time. So now when I push the test set to evaluate the performance of the algorithm, if the algorithm has done well, that means the algorithm has done very good job during the training time. We're able to capture the real pattern inside the data set. But if the algorithm has done very bad, that means I need to retrain. I need to find what's happened. Is it I have poor quality data? Maybe I have outliers I need to exclude. Maybe the algorithm is not good. I need to find another algorithm, and so on. The point is, I need a way to reflect the actual performance for the algorithm. So we introduce what's called testing and validating set. Okay, so validation has also different role. But anyway, I'm not going to cover now because you may be confused. Okay, this is test, then what is validation? We're going to talk about it later on. But same purpose, it's something unseen data to evaluate the performance of the algorithm after training. So testing and validation set are unseen data. Please remember this, unseen data set. That means has not been involved during training time. Okay. Another challenge is hyper tuning and model selection. Let's say I have different algorithms are capable of doing the same problem. Then I need to see which algorithm is performing well. Okay, in order to choose. Maybe just one algorithm for me is enough to achieve the objective. Then I need a way in order to have model selection. I need to choose which model is better than the others. Or I have a case where I need to tune the algorithm. You're going to see later during practical time, some algorithms require you some setup, some setting before you start training. Like clustering. If you remember, in cluster, just now, this is a good example. What did we do before training? We had to provide the number of clusters that we wish to perform training for, right? This is before training. You see fit? Fit comes after. Before training, I have to set up. I have to provide this setting or configuration, if you like to think of them. These types of parameters are called hyperparameters. So if you like to understand, keep a note. Those parameters that you need to set up, that you need to configure before training are called hyperparameters. Now the question comes in. Why did you choose a 3? I didn't choose 4. I didn't choose 5. Okay? So for clustering, we're going to talk about it later. But let's say you are flexible to change 2, 3, 4, 5, 6. And then what you can do, in this case, I'm going to build so many models. I'm going to train different models based on different values, and then try to see which model is performing well. This process called called fine tuning. I'm not sure which is the proper value for number of cluster. So I try different values. I try value of 2, value of 3, value of 4, value of 5, 6, 7, 8, 9, 10. Along the way, I train. Every time I do training on value of 2, training on value of 3, number of cluster, and so on. Then I'm going to later measure the performance for all of these. Based on the best performance, I check what was the value for number of cluster. Let's say I found it was 5. Then I fix the value should be 5. This process called fine tuning for hyperparameter, because these hyperparameter you need to set up by yourself, but you don't know what is the optimal value for them. So we need to go through fine tuning. Okay, so this is also another challenge. Now let's just have discussion, right? Let's decide, we have here different tasks, and let's see whether we need to apply data mining or not. Okay, so the first one, dividing the customers of a company according to their gender. Do you think this kind of task, if you are working in a company, requires you to do data mining or not? No, no. Please raise up your hand if you think no. Who thinks that task A doesn't require data mining? Yeah, some people just know. Okay, I repeat again. Dividing the customer of company according to their gender. Does it require data mining or not? So now raise your hand if you believe it doesn't require data mining. Okay, thank you. You can put down your hand. Who thinks this requires data mining? Raise up your hand. Who thinks this requires data mining to deliver this task? Only one? The rest, majority of you didn't answer. Okay, I repeat again. Who thinks this doesn't require data mining? Raise up your hand. Come on, wake up. You see, wake up. Huh? Okay, who thinks this actually, okay, you can put down your hands. Who thinks this requires data mining? Some people like confused, they're not sure. They put their hands in both cases anyway. Okay. For those who said no, why this one doesn't require data mining? Sorry? Yeah, you can speak up. Nothing gonna happen, huh? I'm not gonna shoot you. So just say. Yeah, exactly. This is simple task. Ask yourself, can you do it? Can, a simple one. Anyone can do, right? Just I need a list of information about each one of you, what their gender, and then I can divide you up, right or not? So this one actually doesn't require data mining. Data mining can do, let's say, but it doesn't require. So you don't need to waste resources for tasks that doesn't require data mining. Okay? Dividing the customer of company according to their profitability. Does it require data mining or not? Who thinks this task requires data mining? Raise up your hand. Who thinks this task requires data mining? Okay, thank you. Put down your hand. Who thinks this doesn't require data mining? Raise up your hand. One. Only one. The rest, 50-50, but you need to choose. Actually, this task doesn't require data mining, does not require data mining, based on their profitability. If you know the profit is made by each customer, okay, then you can just check their profit, whether it's high or low, and then just split them up, divide them up, right or not? Does it require data mining? Doesn't require. Just you need to ask each one of them how much profit you make, and then based on it, you have some criteria to say whether this is high profit or low profit. If it's low profit, you ask them, please go sit on the left-hand side. If you have high profit, let's say more than 10K you do every month, then go please sit on the right-hand side. Right? Simple task. Computing the total sales of company. Does it require data mining or not? This question was in quiz last year, also in final exam. So does it require data mining or not to calculate the total sales of company? Who says this doesn't require? Raise up your hand. Okay, thank you. Who think this requires data mining? Raise up your hand. Please don't be afraid. Even if it's wrong, you are learning. You are learning by experience, by incident. If you don't participate, I'm sure you're not going to learn anything. Okay, let's think about this question. Computing the total sales. If I have a data sheet about the sales for company for a year, what does it require you to do to calculate the total sales in Excel, let's say? What does it require you? Just to call function called sum inside Excel, and then pinpoint to the column that you wish to sum up. That's it. Press enter, you got the total sales. Just 3 steps. Write equals sum, select the column, press enter, you got the total sales for that company. So this is, again, a simple task. Doesn't require data mining. Okay? Sorting a student database based on student identification number. Based on their ID, I need to sort them out. I don't know what identification number. Maybe their ID referring whether they are undergraduate or postgraduate. Do I need to use data mining to sort them out? Or maybe I need to sort them based on their ID, maybe in ascending order or descending order, whatever. Does it require data mining? Doesn't require data mining, right? Just you can write simple query, select from student table, right? Sort by ID, ascending, done, correct? So this one doesn't require data mining. Predicting the outcome of tossing a fair pair of dice or a coin, like it has head and tail. You need to predict, and notice the word, it says fair. Fair tossing, pair of dice, or let's say coin, which has only two sides. Does it require data mining? This is a good one and tricky one. But it's good. It can help you to reason, to think. Who think this requires data mining? Raise up your hand. Only one? Anyone else? Two? Three? It's okay. If you do mistake, that's fine. Here we are here to learn and enjoy our time, huh? Just let's have fun. Okay, four. Who think this doesn't require data mining? Raise up your hand. Also, only one? So total, only 7, 8 students participate. The rest? Who think this doesn't require data mining? Okay. Actually, this one doesn't require data mining. And why? And notice why it says fair. Fair means what? If we're talking about the coin, what is the probability of getting head when you toss the coin? 50%, right? 50% for head, 50% for tail. So in other words, you already know the answer kind of in advance, whether it's going to be head or tail, because the probability is fixed. You have fair tossing for the coin. Data mining is about uncertainty, where you're not sure what the outcome is going to be like. Okay, so data mining is about complex cases where you're not sure, about uncertainty. If it's unfair, then yes. Because unfair, we have no idea what's going to be like. You cannot tell me 50%, correct? It might be 90% head, 10% tail, maybe 30% head, 70% tail. We are uncertain. Okay, while flipping a coin, we already know the answer. For sure, 50% is going to be either head or tail. We already know the answer in advance. So this is not data mining. Predicting the future stock price of company using historical record. Do you think this requires data mining? If yes, raise up your hand. So now I'm talking about F, task F, predicting or forecasting the future stock price of company using historical record. If you think this requires data mining, raise up your hand. Okay, your friend has raised it too much, showing that high confidence. He's sure that this requires data mining. Good. Who think this doesn't require data mining? Raise up your hand. Okay, good. Actually, this one requires data mining because this kind of task is difficult to do. Okay, we cannot predict easily. It requires forecasting process where we go with time series and then study the trend, the seasonality of the data, and so on and so forth. So this is kind of task which is not easy to predict. We require data mining. Monitoring the heart rate of patient for abnormalities, outliers. Does it require data mining? Yes. This is anomaly detection. We need to capture the heart rate for a patient and then pinpoint if there's something abnormal about his heart rate. Okay, so it requires complex process. Maybe you're going to capture pressure, I don't know, many things, other data, in order to try to pinpoint whether there's something abnormal about his rate or not. Of course, by the way, some of you might still like blur. So where's data mining? Maybe if the heart rate is over, let's say 80 in 1 minute, 80 beats in 1 minute, then this is abnormal. This is traditional programming. But sometimes maybe abnormal means based on other criteria exist, based on maybe his pressure, maybe this kind of pressure requires data or heartbeat to be in that level. So abnormal, if it's unusual for a person who in that pressure, in that condition, to have this heartbeat. So there are more complex things in order to achieve or to know whether it's abnormal or not. Okay? So abnormality means we can apply anomaly detection. Monitoring seismic waves for earthquake activities, of course. Data mining, extracting the frequencies of a sound wave. This is not data mining. Just you extract the frequency from a wave of sound wave. This actually has nothing to do with data mining at all. Okay, this one forget about. Data mining methodology. Now, some of you might have chosen to work on FYP, which requires AI, data mining, or maybe, not maybe, or all of you are gonna go also with assignment for this course. So you need to know the right way to proceed or to achieve data mining project, how to do, what you need to do when you need to work on data mining project. Now, if you are working on traditional system, you can go with SDLC, right? SDLC methodology, where you're required to collect requirements, then design or analysis, design, implementation, maintenance, and so on. But when we go to data mining, it's not just that simple, okay? We need to go through different process. So this is why I have included, or actually part of your syllabus where you need to study about data mining methodology, okay? So one of them is called KDD, knowledge discovery in database. This is in the short format, in simple one. Before you conduct data mining, as you see here, okay, you need to do data pre-processing, and you have also some post-processing. So data pre-processing can involve many tasks as well, like feature selection, dimensionality reduction, normalization, data subsampling, and so on. Post-processing means after you have done data mining, you may also wish to do some tasks like filtering pattern, visualization, integration with other tasks, or maybe in the overall project, and so on. Let's look into more details. You can skip this one. I'd like to focus on CRISP-DM, the one that you need to use for your assignment. CRISP-DM is cross-industry standard process for data mining. If you notice, this figure involves many stages or phases. The first one is business understanding, meaning that you need to understand what is the problem, what you are trying to achieve. Let's say you are working in a company and they ask you to be involved in a project for machine learning. Then what do? Does you say, hey, I'm happy now, I'm gonna work in machine learning, and then tell me please, where's the data? Let me just start typing. I'm very good in Python. Of course, this is very wrong way. Firstly, what you need to do, you need to go and sit down and ask them, what is the problem? What you are trying to achieve, okay? So you start to collect requirement from them. What is the purpose of this project? Why they need to do it? How it's useful, how it's gonna be useful, how they're gonna apply it later, okay? And so on. So you start to collect requirement from them. This is called business understanding. Business understanding, where you try to understand what is the actual problem, what is the objective, why they try to achieve this one. Maybe from also the objective from business overview. I mean, from business perspective, if you are talking to your manager, maybe they have no idea about data mining, right? But they have perspective maybe to increase the sales by 20%. So you need to write down, okay, so the objective is to increase sales by 20%, let's say by the end of the year. But from data mining perspective, this might be requires you to have a good performance for your model. So you need to start collect all these requirements and try to interpret, understand what you are supposed to do. So this one is under business understanding. After you have clear picture about the project, what you need to achieve, what are the objectives for this project, and so on, then you need to move on to data understanding, where you try to inquire what data is available for this project. What kind of data is available for this project? Where the data coming from? Is it coming from machine inside the factory, or is it coming from where? So you need to understand the source of the data coming from where, and what is the data itself. So I have column 1, column 2. Let's say I have 100 columns. What does column 1 mean? What is column 2? What is column 3? Okay, so you need to understand what is behind them, what these columns are. Okay, so data understanding requires you to know the source of the data, what these data are. Okay, and another thing on the data understanding, you need to explore your data, find out what is the quality of this data. Does it have outliers, missing values, okay, and so on. So this is all under data understanding. So in data understanding, the output is going to be understanding where your data coming from, writing report about the quality of the data, whether there's missing values or not, what is the percentage of missing value for each feature or each column, whether there are outliers or not, and so on. But you don't take any action, just to report about any quality issues inside the data set. Then you move on to stage or phase number 3, which is data pre-processing. Now, based on data understanding, maybe you have found or you have reported, let's say, for example, about quality issues, outliers, missing value. Now, the action should be taken under data pre-processing. So after you have done data understanding, then you can go through data pre-processing. Maybe based on data understanding, you found out that there's outliers in this feature. Then in data pre-processing, you need to take action. You need to rectify these outliers. What are you going to do with them? Are you going to remove them from your data set? Or are you going to provide treatment? Same like for missing value and so on. Of course, data pre-processing involves more. Maybe data transformation, we're going to talk about later. Data feature scaling, we're going to talk about later, where we change the scale of the data and so on. Then only we move to modeling. Modeling, where we train the algorithm, where we call, let's say, classification algorithm, and we call fit. We model, start modeling our algorithm, train them. Then we go into evaluation. We evaluate our algorithm. We're gonna say later, we're gonna talk later. In modeling, also there's some evaluation we're gonna do based on the validation set. That's why I mentioned earlier there's testing and validation, right? The earlier slide. Inside modeling, we do validation. Inside evaluation, we use testing set. We're gonna discuss about it also later. But during evaluation time, we go and evaluate the performance of our model, our algorithms, and see whether based on business understanding, they're gonna fulfill the requirements for this project or not. Maybe you have set up the accuracy for your model for classification should be 90%. In evaluation time, you found that the accuracy is 80%. So it does not fulfill the requirement under business understanding. So that means you need to rectify the issue. What's happened? Is it I need to acquire more data? Is it my data is irrelevant? Remember the challenges just now I talked? So you need to all go explore, see what's happened. Is there overfitting, underfitting, irrelevant feature I'm providing? So you need to go through the list, see what problem, and try to rectify. Then later on evaluation time, you should try to achieve the 90%. Once you achieve the 90%, that means you have fulfilled the requirement for this project. Only then you go to deployment. Deployment means using the actual model for real life. That means now is my project ready to publish. Like if you are working on any project, right? Only when the project fulfill all the criteria what is required, then you publish, you give your final product to people to utilize. It's for registration or time attendance, then we can use, apply, or deploy inside the university. Then we can, lecturers can use, student can use as well, and so on. Okay, any question? Actually, almost done. For exploration, this is also provided a checklist. We're gonna talk next time how you can also do, there's a full checklist you can follow when you work on any project. This is for the hands-on machine learning book. It's one of your main reference. You can explore. We're gonna talk about next week. Okay. Also, I have provided explanation. There's video on YouTube explaining to you CRISP-DM again. Okay, so you can go through it and watch it. If you have a question, you can post it in the discussion WhatsApp group.